My name is Dagmara Pineska-Śmietanko and I am working in the Institute of Nuclear Chemistry and Technology in Warsaw, Poland. As one of the co-authors, I would like to present invention entitled Inorganic Ion Exchanger of the core shell type with magnetic properties.
Nowadays, there are more than 440 nuclear fusion reactors located in 30 countries, generating about 12% of the world's supply of electricity. Most of commercial nuclear power reactors are light water reactors in which light water serves as coolant, which removes the heat produced inside the reactor core by the nuclear fission reaction. Moreover, water is also moderator which slows down neutrons that are released in the nuclear fission process. The main function of the primary water circuit is to transfer heat from the reactor core to the steam generators. Additionally, primary coolant loop is a barrier that captures any fission product that escape the fuel. Water is also the most common media used to store spent fuel after being removed from reactor core. Fuel rods are being stored in pond for over 20 years. Main sources of the radioactivity of cooling water in primary water circuit and spent fuel pools are the products of uranium fusion, which are realized to the cooling water from fuel cladding flaws. To this group, for example, cesium radioisotopes belong. Cesium radioisotopes pose a serious threat to the humans and the environment because have a long half-life. Cesium is characterized with high mobility and may remain dissolved or be adsorbed on sediments. Then is easily bound by plant roots from solution and can be translocated to the shoots. In the next step, cesium can incorporate into edible animal tissue and concentrate in milk. Cesium concentrates mainly in muscles. Bioaccumulation of radiocesium in the body can increase the cancer risk because of the tissue's exposure to the beta particles as well as high-energy gamma radiation. Therefore, cesium radioisotopes needs to be removed from water. Inorganic ion exchanger core shell type with the inner layer composed of iron oxide and the outer layer composed of transition metals hexacyanoferrates is dedicated to this application. Simple method of the one-step synthesis inorganic core shell ion exchanger based on iron oxide particles involves the coating of the iron oxide particles with layer of the transition metals hexacyanoferrates containing cobalt, copper or zirconium. Then obtained material is washed and dried. Small size of the ion exchanger particles leads to higher and more developed specific surface area, what results in effective sorption kinetics and higher adsorption capacity. However, separation of these small particles of ion exchangers from the solution still generates problems. Therefore, magnetic properties of the core shell ion exchanger particles based on iron oxide facilitate its separation from the treated solution. The material obtained according to presented method has many advantages: well-developed specific surface, good mechanical resistance, chemical stability in wide pH range, resistance to ionizing radiation, fast and effective sorption of the cesium radioisotopes, high sorption capacity for cesium radioisotopes, magnetic properties of sorbent particles allows also easy separation of the sorbent particles after cesium removal.